Next curve.
Hey everyone, this is Leonard Lee, Executive Analyst at Next Curve, and I'm here in way too sunny San Francisco with Nitin Kumar of Qualcomm. How's it going, my friend?
Hello, Leonard. Doing great. How are you doing?
What are you doing here?
Just awesome.
Yeah, well, so you've released some great news today that I don't think we'll have to find out whether or not we can talk about it or not. But what I really wanted to talk to you about, okay, is let's talk about NPU, because everyone's talking about the AI PC, and I'll have to be honest with you, people are still scratching their heads about it. But the net new thing that everyone's talking about is the NPU, and I think I'd love to get your perspective on why it matters and how it defines the AI PC. And, you know, how's it different from GPU? Because, you know, a lot of people associate AI with, quote unquote, the GPU as being sort of the accelerator. But, you know, you have this thing called the NPU, actually, that, Qualcomm, through its Snapdragon products for the smartphone, have been, you know, you guys have been doing this stuff for a long time, right? Yeah. It's not new.
No.
But it's apparently new for the PC. So let us have it.
Absolutely, Leonard. So we'll start. And I'll start actually from there, that as you said it, right? We have been doing AI as Qualcomm and Snapdragon. We've been investing in AI technology for over a decade now. Yeah. If you go back and look at our dedicated AI engine cores, NPU or hexagon processors or hexagon NPU or HBX processors, we've been integrating that onto our system on chip for probably 8 years now, if I'm not wrong, somewhere around that, with the research going more than a decade. And even on the compute platforms as well, our prior generation, which was launched before X Elite, that was Snapdragon 8CX Gen 3, that was announced at Snapdragon Summit in 2021, had 15 TOPS of dedicated NPU capability back then, where our competition is catching up now, but that had 15 TOPS of capability back then. So even on compute, we've been adding these for multiple years and multiple generations.
Now, you know, on the endpoint, when we talk about AI, and I think people just generalize AI too much, we have to be very specific about what we mean by AI, right? AI is very, very broad. But even broadly speaking, you know, in terms of endpoint devices, smartphone has been pioneering a lot of the AI type applications, right? And workloads handling, silicon basically geared toward being able to handle AI workloads very efficiently on very power constrained devices, right? I mean, that is literally, in my view, where you guys are coming from as we look at the greater evolution of AI and computing models. The way I look at it is that is sort of that legacy angle that you guys are taking. What do you think? Did I get it right?
Yeah, absolutely. And that's you nailed it actually. And that's the unique advantage that we bring in this solution. I'll touch on the previous question that you asked as well, right? Like, what's unique about the NPU versus the quote unquote AI with GPU sense there, right? Like, when you look at different AI applications, or what is really like AI, there's training and then there's inference.
Right.
So rightfully so, maybe when you're doing training the models and you're generating those models, a lot of compute in the cloud, possibly GPU as one application, or could be others as well. But when you look at how do you want to use that AI for your benefit, what you as Leonard can do, what I can do, what somebody else can do with that AI, you want that AI inference, using that model to generate something for me that I want to see. That's inference running locally on the device. And that's a very different AI application when you want it quick, you want it personalized for you, you want that tuned for your needs. And for that, running locally on the device with no latency and personalized, dedicated NPU is the right architecture where you can run it. AI models can also run on GPU and CPU. We also support a heterogeneous architecture where AI is pervasive. We have a full AI engine model, but a large set of AI models will leverage the NPU capability where we have 45 tops of NPU on our X Elite platform that runs locally all those models, all those inference when you need it the most.
So really, it's allowing you to take some of that legacy that you guys have been involved with on smartphone, highly constrained AI computing, and then bring it to the PC, and then expanding the portfolio of silicon IP that can be used to support a broader range of AI applications, right? Like, I know that you guys talk about generative AI quite a bit, and everyone knows my opinion about that, even this guy, believe it or not. But, so I know that you guys have like this position of looking at the NPU having a really important role in hosting some of these on-device large language models. By the way, these demonstrations you guys have done of like stable diffusion on-device, demonstrating like sub 1 second.
Yes.
Yeah, rendering. That's technically very impressive. Do you know what I'm saying? So I think that for me that has really been the takeaway. But also in Barcelona, I mentioned this to your team. One of the most impressive things that I saw was the work that you guys are doing with Blackmagic Designs with their DaVinci Resolve. There's that magic mask function. I thought that was really cool, and it was for me a really concrete way of experiencing and seeing from let's say a creator's perspective, because I am a creator. Why this would be valuable. And I know that you guys ran that on NPU. So under the hood, how does the NPU impact and enable workloads like that? And what difference does it make?
Absolutely. I'm glad you saw both the demos. We did a stable diffusion demo. We also did the Blackmagic DaVinci Resolve demo as well.
See a lot of demos, my friend. See a lot of demos, buddy.
Awesome. We have a lot to show.
I know you do. You have a lot of demos to show. Yes.
There's just a lot of technology that we've built in, and we want to showcase, and we want everybody to utilize that technology. But going back to you, the DaVinci Blackmagic is an example, right? Like when you're using that video or creative software, or the video creation, or you're running that photo editing software, like GIMP as an example, another one, right? A lot of that fine tuning that you want to do, that applying that magic mask filter, when you break down that algorithm, a lot of that algorithm is aptly tuned to be running on the NPU and leverage those NPU instructions, those matrix instructions, those transform instructions, to leverage that core of the NPU as the right suited hardware block for that software. And we've worked very closely with Blackmagic Design to optimize that and port it on the NPU, so that it runs much faster and at a better quality as well. From that perspective, that drives the experience of the user. As a creator who's using that, now you can do a lot more in a short span of time. You can play around with the different filters as well, or different applications. You can generate different videos. You can apply different masks that produces a better output quality of your video. That whichever one you are generating. And there are plenty of those across the creator space, across productivity space, with code generation as an example, where you can use CodeGen as an example to write code, where you can tell CodeGen to, write code for me, write a binary sort algorithm code for me, and CodeGen will generate that for you, because that is aptly tuned and optimized, running on our 45 tops NPU, that can improve the productivity for you as a software developer, as a video creator, and multiple other applications.
Okay, and as far as the NPU itself goes, it kind of has this reputation of being power efficient, but then here's my impression, of how people talk about it, that it's not as performant as, let's say, a GPU. Would you guys agree with that? Is that what you guys are seeing in some of your benchmarks and testing?
No, I think it depends on the type of the models. There can be certain models where, let's say, on a very large, high precision models, the GPU might be the better to run those high precision models. But for a large set of models, a large set of algorithms where like the ones that we just discussed about, or could be a different one, like stable diffusion as another one, right? Like all that, I think you can quantize it, you can run it on the NPU much faster for a high quality output that is acceptable for that use case.
Right.
But running more on the NPU also gives you a key advantage, which is in terms of power consumption. And that enables you to run some of these models all the time in the background. Some of these models can all be running on the NPU on a very low power budget, if you will, and trying to learn more about you and your system so that the next query that you run, the next model that you run is more personalized for your needs.
Yeah, you know what? I was thinking, so these new AI PC SoCs you guys are putting out there are actually heterogeneous AI SoCs and processors, right? How do you like that?
Absolutely. Heterogeneous AI. I love it, Leonard.
Just
love it.
Invented it here.
Invented right here.
AI.
Heterogeneous AI. Love it.
You heard it from Nitin. Well, anyways, my friend, thank you so much. Really appreciate you sharing your time. And then thanks for the folks at Qualcomm for inviting me to the special event that I can't really talk about, except it has something to do with X Elite, Snapdragon X Elite, coming to you very, very soon. Remember to like, share, subscribe to the Next Curve podcast, which is the reThink podcast at www.next-curve.com. We're on YouTube as well as on Buzzsprout. Just look up Next Curve and subscribe. And we will see you next time. Again, thank you so much.
Thank you, Leonard. Thank you for your time. Take care.